predicting product. Whenever any solid, liquid, or gas forms, we should predict the product. Again, whenever any solid, liquid, or gas forms in the product, we should predict the product or write in the right side of the equation, which I'm arrowing to. We should predict the product. It's a really kind of hard concept, guys. Students usually have a problem in this. So it's not only you, okay? So it needs practice and basically being good in nomenclature and writing formulas. So if you are not in the writing formulas and naming, please go back to nomenclature video and of the ionic and molecular formulas, and then come back and continue here. So the first thing we're gonna do, we are going to write the equation. We're gonna have they're gonna give you the left side of reaction, and you should predict the right side of the reaction. So here I have Ag2O plus NaCl. How we can predict the product, guys? I told you what type of reaction is that. Let's first focus on what type of reaction is that. Is double. Why is double displacement? Because I have one cation, one anion. In the second compound, one cation, one anion. So it's a double displacement. Then we said to predict the product, we should basically first switch the anions. So, or switch the cations. Then I'm gonna switch the cations, okay? Please make sure don't move the subscript from the left side. So we should predict the product, just switch the cations. So that's the cations. I just switched the cations. Ag was with oxygen, now is with Cl, and Na, which was with Cl, is now with O. If you pay attention, I did not move the subscript, okay? Why do you think I should not move the subscript? If you remember from the nomenclature for a video and formula, these two is when you have this formula, this subscript is from oxygen here, like because oxygen is 2 minus, right? So based on cross rule, is gonna be the subscript of Ag. But here we don't have oxygen, so we cannot really move these two. So please, as a rule, never move the subscript whenever you predict the product. Then after you only switch the ions, you're gonna then check the subscript. Check the subscript. So I'm gonna check the subscript. Okay, Ag we know is Ag plus, chlorine is chlorine minus, right? Okay. So what's gonna be, is it correct formula, right? Yes, plus, because I have AgCl plus and minus cancel out. What about here NaO? Oxygen is 2 minus, right? What about sodium? It's plus 1. So based on the cross rule, we're gonna put 2 as a subscript of Na because oxygen is 2 minus. So now I check for subscript, make sure I have the correct subscript. Then I'm gonna use solubility rules. See, okay, I have AgCl here, right? So I'm gonna go to the basically the solubility rule table. What is AgCl, guys? Look at the poly. I will recommend you put the solubility rule table in front of you and check with me. Is it AgCl solid or not? All the chlorines are soluble except when they combine with some ions like Ag. So AgCl is solid. I'm gonna put SN next to it. What about Na2O? We said all of the oxides are insoluble except when they're combined with some ions like sodium. So it's gonna be aqueous. So we're gonna check the subscript. You might ask, okay, until I don't predict a product, I cannot really tell if the reaction happens or not. You are correct. We should first predict the product, and then based on if I have a solid or liquid or gas in the product, then I'm gonna write on next to it if it's no reaction or not. Here, because I have a solid, reaction is really happening. Then the last step is balancing the chemical reaction. Okay, I'm gonna balance the chemical reaction. Make sure recheck after you balance chemical reaction. Let's predict the product for this equation. So I have these two compounds in the left side. Then I will switch the cations here. So I will have NaCl. So Cl comes next to Na, and CO3 comes next to copper. So that would be the product. Then we should check for subscript. We never should move the subscript. Why, guys? Because the compound is completely changing. We cannot move the subscript in the right side. Only move the element or polyatomic ion. So make sure when you move the polyatomic ion, all of its basically stuff or is gonna move in the right side. Okay. So then, okay, let's check the subscript. So NaCl, Na is +1, Cl is -1. Okay, guys, make sure if you move the carbonate or polyatomic ion, all of it move, because we said before, polyatomic ions never are separated from each other. Okay, so now let's check the subscript. Na is +1, chlorine is -1. So that's the correct one because positive and negative cancel out. What about CuNO3? Here, you should pay attention to the charge of copper. The charge of copper was 2 here. So you're going to use the same charge that you have for copper here. So it's 2, right? So here the charge of copper is 2 plus. What about the nitrate is -1, right? So then the charge based on cross rule, the charge of copper is the subscript of nitrate. So we check the subscript. Then we should check if which of them are soluble or insoluble. NaCl, we know that is basically is aqueous because all of the group 1 elements are 1A elements are soluble, so we put aqueous. CO3, oh, CuCO3 بود اشتباه کردم. Okay, guys, when you move, make sure the carbonate, which is polyatomic ion, should move completely. CO3 2 minus should move in the right side. Okay, uh, we basically, as I said, we switch the cations. Now let's check the subscript. Okay, guys, when you switch the cations, make sure and don't move the subscript as I said, but the polyatomic ion always move basically with all its components because they are never separatable. So now let's check the subscripts. Okay, NaCl, Na plus Cl minus, so the charges cancel out, that's correct. You do not need any subscript for NaCl. What about this one? For the finding the charge of copper, you should go back to here. Charge of copper in the left side is 2 plus. So you're going to use the same charge. So copper is 2 plus, carbonate is 2 minus. The charges cancel out. So that's the correct formula for copper to carbonate. So let's see which one is soluble, which of them are not. So NaCl is soluble because from the solubility table, all of the group 1 elements are soluble. Copper 2 carbonate, all carbonate are basically insoluble except the ones that I mentioned. Copper was not one of them. So copper 2 carbonate is solid. So we're gonna put copper 2 carbonate solid here, and then we're gonna put NaCl as aqueous. It does not matter, guys, which one you put first. It doesn't matter first you put NaCl here or copper 2 carbonate. But what I'm looking for is the correct subscript and correct formula for each of them. Make sure balance at the end. So that's the balance equation at the end. And then, as I said here, because I have a solid, here I have reaction happens. But if you don't have a solid form here, it was no reaction. But here, actually reaction happens. In the exam, if you see solid or liquid or gas, write down reaction happens. But if you do not see solid, gas, or liquid in the product, no reaction happens. You should write it. Okay, guys, let's see how we can write the total ionic equation and net ionic equation. Here, what you see here is the molecular equation. What is a molecular equation? In molecular equation, you see a compound like AgNO3, which has its own cation and anion, right? That's the molecule, right? We said that molecule is the one or more elements give us the compound, right? Or molecule, right? So that's the molecule of AgNO3. What about NaCl? That's the molecule of NaCl, right? Is 2 or more elements. The same for AgCl, the same for NiO3. So that's why this is called molecular equation. So the name of this equation, chemical equation, whenever you see some compounds give product, some produce some compounds, this is called molecular equation. Now, what is net ionic and net ionic equation and complete ionic equation? In what does it mean when you basically hear ionic? It means we need some positive and negatives, right? Ions, right? Positive and negative charges. So when we have that, we should basically separate these molecules from each other to write down complete ionic equation. Again, when we write complete ionic equation, as you see here in the bottom that I'm arrowing, it means you should make them as ions. So, and we should be really good in charges. How you find the charges of each of them? From the cross rule, right? Do you remember cross rule? So the first one is Ag plus, right? Ag plus. Where I got it? Nitrate subscript. Basically, there is no subscript. This is the 3 is a subscript for the polyatomic ion, but is no parentheses basically, and there is no number outside of parentheses. So we assume we have only one nitrate. So it's gonna be Ag plus. Then you should make sure whatever is the compound state is gonna go next to Ag plus. So where these aqueous come from? From the right side of AgNO3. Whatever state is AgNO3, come just copy it from here to here. Then NO3 minus. I'm gonna write it down. I have only one, so make sure, pay attention how many of each you have. Then I have one Na plus, and I have one Cl minus. I just copy the states here from the actual chemical equation or molecular equation. The only important thing in writing complete ionic equation is that never ever try to separate solids, liquids, and gases. Okay, in writing complete ionic equation, never ever try to separate solids, liquids, and gases. So for the writing complete ionic equation, you should have all of this information. You should have the states. If you do not have them, you should find it from the solubility rule table. You should know basically you should have a correct balanced chemical reaction. So you should have everything ready for writing the complete ionic equation. So we said that we never separate solids. So we should write it as it is, copy from the molecular equation. Then I'm gonna separate the NiNO3. Why? Because it's aqueous. We should separate aqueous. Whenever you have aqueous, we should separate them to ions. Na plus, where does aqueous come from? From the state in front of or in the right side of the NiNO3. The same for here. So that's a complete ionic equation. Then we should write from complete ionic equation, net ionic equation. What is net ionic equation, guys? In net ionic equation, we should cross out the ones that are repeating in the both sides of this equation. So which of them are repeated here, guys? Nitrate, right? Nitrate is repeated in the both sides, right? So we're gonna cross out to find the net ionic equation. We are going to cross out the ones that are the same in the both sides. So nitrate is the same. I'm gonna cross it out, and I'm gonna cross out the sodium here. So what is remain, guys? Ag plus, Cl minus, and AgCl. So this is called net ionic equation. This is what is really happening inside the reaction, because this is the solid that's formed. What is important for us is basically actual seeing really what's happening. We want to see what's happening basically. Here we see a precipitation happens. So These ones that are cancelled out, I said in the both sides, are called spectator ions. So as I said, this is called net ionic equation, and basically clearly shows that what is happening really in this reaction.